my name is Jim. We're going to be talking about this compact impact wrench today on
Kilimanjaro.
This is the Dewalt compact impact wrench. It's model number DCF921, and it's from their Atomic series. So the Atomic series is meant to be a smaller tool, but still have plenty of power for what you need to do. And in general, I found that to be the case. In case of this impact wrench, it puts out 450 foot-pounds of breakaway torque and 300 foot-pounds of fastening torque. At least that's what they claim. We'll test that a little bit later. So you may ask what the difference is between an impact wrench and an impact driver. So this is an impact driver, also from their Atomic series. You can see they look pretty similar. The main differences here are impact wrench tends to have an anvil on the end like this, a square 1/2 inch anvil, or a 3/8 inch one for a little bit smaller tool, while this has a 1/4 inch socket on the end. The other difference is these tend to be a little bit bigger. Now in performance, there's a vast difference here. This puts out about an order of magnitude more of torque than this guy does. Now, why would you ever use an impact driver then? Well, for one thing, they're lighter, but for the other is when they're driving a screw, they impact in the axial direction, pushing the bit into the screw and the screw into the work, helps prevent them from camming out, and they go a little bit faster than an impact wrench does. An impact wrench only impacts in the rotational direction, which is great for torquing down a screw or a bolt, but it may not help you with camming out in a screw that you're trying to drive. This is part of DeWalt's 20-volt line, which means it can take any of the 20-volt batteries that DeWalt sells, all the way from these little 1.7 amp hour power stack batteries, all the way up to these big old monster 9 amp hour flex volt batteries. They all work with the tool. You can see it looks a little bit goofy and it's a little bit unwieldy with that big battery on it, but it works just fine. With these little batteries on it, it's a lot more manageable, a lot lighter, a lot easier to use. Of course, you're not going to get the runtime. Now, when I was doing the last impact wrench test, I got some flack for using the small battery here, and then I claimed it didn't put out the rated amount of torque. It's true the smaller batteries don't put out as much power as the bigger batteries do, although the power stack batteries are supposed to be better at that than the regular batteries that they sell, like these XR ones. But in my opinion, if it says in the box it's good for 450 foot-pounds, it should be good for 450 foot-pounds with any of the batteries that work in the tool that DeWalt sells. So I'm going to test today with the smaller batteries, and I'll probably do most of the testing with a medium-sized battery, something like the 6 amp hour battery, which is probably what the most common one is going to be used with this tool here. On the tool itself, we start up top, we have a 1/2 inch anvil, and it's got a friction ring type, so that means that it's got a little ring around the front of it with a little rubber O-washer underneath that pushes that ring out. That means that you just take the socket and you can just slide it right on and then just pull it right off. It's pretty stiff. That may just be because it's a fairly new tool, may loosen up over time, or it may just be how it is. It's not too big a deal, but they are a little bit, sometimes they do get a little bit hung up on the end there. I do like that better than the alternative though, the pin detent version. I find those are a little tricky to get the sockets off sometimes. Now, at the bottom here, we have a nice little control panel that I'm glad they've added to this. It's got a couple different functions. The first is that it's got an LED function, so you can adjust the brightness of the LEDs that are up top, and you can also turn those LEDs on without having to pull the trigger if you need a little flashlight or something. So you can have it set so those are on the kind of dim setting, a brighter setting, or just completely off. And it remembers that setting, so it uses them all the time. Even if you take the battery out and put it back on, it remembers what setting you have. So right now I've got it turned off, and it doesn't turn the LEDs on. Generally though, I do like to just keep it on the brightest one. I do wish those were just a little bit brighter. If you're outside working, somewhere and there's a bright sunny day, but where you're working is kind of in the middle of an engine bay, it's in the shadows, sometimes it can be a little hard to see what you're doing, and these LEDs might not be bright enough then. So I do wish they were a little bit brighter. Now the other thing that it has down there is a mode selector switch. So this has 4 modes. So it has obviously the fast mode, or the slow mode, the fast mode, and then it has 2 special modes. It has a bolt mode where when you're tightening, it will spin it up real fast until it catches, it'll hit it once, and then it'll pause for a second, and then it'll continue impacting and put the full amount of torque on it. When you're loosening, it'll impact it real hard until it breaks loose, and then it'll slow it down a lot so that the nut doesn't fly off the end of the bolt that you're working on. I really like that mold. I don't like it so much for fastening. I tend to assume that when it hits the one time and then it stops, that there's something wrong. Maybe it's just a matter of getting used to it, but I could see it being useful where you're trying to not over torque a bolt. You just wait and slams it on, hits it once, and then you stop and you go get your torque wrench to put the final torque on it. Now it's also got this other mode. It's called a timber screw mode. I'm going to try that out in a little bit and kind of show you, but in my opinion it doesn't really do a whole lot, and the book just says that it's optimized for timber framing screws. Don't really understand what that means by optimized. But we'll try it out and see how it works. All right, let's start off with some real world testing here. So this is probably the most common use for an impact wrench, is taking lug nuts off a car here. So these lug nuts were put on about a year ago. They haven't seen a winter cycle, so they aren't going to be that corroded. I torqued them to 129 foot-pounds back in the spring when I put these on. So it should be well within the capabilities of this impact wrench here. I've got the little power stack batteries on just to see, that's kind of the worst case scenario for this. And I've got it set in the machine screw mode here. So you'll notice that after it breaks the lug nut free, it slows the impact wrench down pretty significantly so it doesn't come flying off when it falls off the end of the bolt here. So let's give it a shot. So you can see it's going real nice and slow here, so it doesn't come flying out, which is pretty nice. And it had no problem getting that bolt off, that lug nut off. All right, now to show you the other feature of that machine bolt function on here, I'm going to put the lug nut back on. You'll see it'll spin it on real fast, and then it'll hit once, and then it'll stop for a second or so, and then it'll continue to impact. And that gives you some time to stop if you don't want to over tighten the bolt. So, and you should never put a nut on straight on with an impact wrench because you might cross thread it. I'm going to be real careful with that just to show you here. So you see it hit once, and then it pauses, and then it hits a whole bunch more to tighten it all the way down. So there are some difficulties in measuring just how much torque this impact wrench will put out. First of those is that it doesn't take the same amount of torque to loosen the bolt as it does to tighten the bolt. I've done some testing with my torque wrench here, and I found that it takes about 20% more torque to loosen this bolt in particular than it does to tighten it. So that's what we're going to go with to try and see how close this gets to its spec values. The other problem though is that 450 foot-pounds is an awful lot of torque. So that means if you've got a 1 foot bar, you put 450 pounds on one end of it, that's how much torque is going to be put out on the other end. That's way more than a car lug nut's going to take. A bolt like this is a 1-inch diameter bolt. This is supposed to be torqued up to about 650 foot-pounds, so it should be able to handle torque for the testing here. Problem is, how do I tighten this bolt up to a high enough level? So that's why I've got this big old board with a big old wrench bolted into the board, and I can take this board and bolt it down to my workbench, and then from the top side, I should be able to get up to a fairly high level of torque. We'll see just how far I can get here. I've got a big breaker bar, so we're going to tighten this bolt up pretty high and see how well we can go on here. I'm going to start off pretty straightforward here. So this is a 1/2-inch torque wrench, and it goes up to 150 foot-pounds. So I'm just going to tighten it up to the 150 foot-pounds, the highest this will go, and see if this can get it off. Now, since this is rated for 3 times that, shouldn't have any problem. Let's give it a shot. All right, there we are. Now I'm going to have this in the 2 mode, the fastest mode. Let's see if we can get it off. So it can get it off, but it took it quite a long time to do that. So to torque this higher than my 1/2-inch torque wrench goes, I don't have a bigger torque wrench, but I do have a 40-inch, 3/4-inch drive breaker bar here. Now of course this won't by itself measure the torque, but I also have a little scale here that I can hook on the end of the breaker bar, see how much force I'm putting on the end, multiply that times the 40 inches, and figure out how much torque I'm putting on here. So let's torque this up. We'll see how high I can get it up, but I'm going to end up start spinning my whole workbench here at one point. I was having a real hard time pulling on the end of this force gauge with enough force to really torque this bolt down. And I realized I have a big old hunk of iron here that I can strap this to and pull as much as I want on it. So I've got a strap clamp hooked up to the force gauge here on the end of my 40-inch breaker bar. And this is really nice because I can move the table on my Bridgeport to pull more on this. I can pull on the strap clamp and I can adjust the table this way to keep this at a nice 90-degree angle. So I cranked this up to 115 pounds on here with a 40-inch lever arm. That's about 380 foot-pounds of torque. If you assume that it's going to take about 20% more torque to undo this bolt than it did to tighten it, that should put us right around 450 foot-pounds. So let's undo all this whole setup here and see if it can break it loose. So I've got an 1.5-inch socket here mounted directly onto the impact wrench. If you have a bunch of adapters going in here when they wiggle around, or extensions on here like this, that's going to sap some of the torque that the impact wrench puts out. Here's the torque wrench, it doesn't matter, it just all bears up on each other, but with an impact wrench everything's kind of bouncing around. You can lose a lot of torque using a bunch of adapters like that. So I've got it on the 2 setting here, I've got a fully charged 6-amp-hour battery. Let's see if it can undo this. About 450 foot-pounds of torque. You can notice I have some ear protection on because I was just going to rattle around a whole bunch. So it doesn't seem to be able to do it with the 6-amp-hour. We'll turn out using the big battery here, this 9-amp-hour battery, see if it's able to do it with that. it doesn't seem to be able to do that. So let's take this apart. I'm going to torque it up to 400 foot-pounds instead. We'll try it again. All right, so I went and retorqued this to 333 foot-pounds. So with a 20% factor for breaking it off over what it took to torque it down, this should take about 400 foot-pounds to undo. Let's see if it'll be able to do that. Alright, so I was able to get that off. I don't ever have any problems taking out bolts that are clean and have been sitting indoors all their life, even if they were torqued to a pretty high level. Usually when I run into issues is a bolt that's been sitting out in the weather, it's got a lot of corrosion on it, and it's very difficult, it's all rusty and stuff, so it's hard to get off. So I wanted to try that. I don't happen to have any bolts around that are rusty that I could try it on, at least not any that I want to take out. So I'm going to make up one. So what I got here is 2 steel plates, a little bit of wood in the middle just to act as a spacer, and a 14mm bolt going through it. So I'm going to take that, I'm going to put it in a little container here, pour some vinegar on it so that it corrodes pretty quickly, let that sit for a week or two. Hopefully I'll get some good rust buildup on there, and hopefully it'll get nice and corroded and very difficult to get apart. So I'm going to try that. If the vinegar doesn't work, I'll probably switch up to something a little stronger, sulfuric acid or something like that, to make sure that this gets nice and corroded. So for the steel plates, I didn't want to just leave them bare. I wanted to put some protection on them so they just didn't turn into one giant block of rust. I also wanted to see kind of how well spray paint works as a corrosion protection. So I put some spray paint on here. I used 2 different types. On the gray side here, I used this self-etching primer with this Rust-Oleum gray paint. And then on the other side here, on this green side, I used this clean metal Rust-Oleum primer and this bare green premium paint, just to throw a little bonus test in there for you. So I'm going to take this, I'm going to torque this up to 130 foot-pounds, which is higher than an M14 bolt's supposed to be torqued to, but it's the torque level that I torque my wheel nuts to, and so it should be a good test for a corroded wheel nut and see if the impact wrench is able to get that apart. So I'm going to put it in the vise here and just torque it down. Alright, there we go. I'll stick it in the container and let it corrode for a couple weeks. It didn't end up getting nearly as rusty as I was hoping for. It did get pretty rusty. All the paint failed on the 2 steel plates that are on here, but it is what it is. I think I had it soaking too much in the vinegar, not like in the vinegar fumes. I think that would have worked better. Also, if I had some airflow going through there to get some more oxygen on this. But anyways, we'll try it out, see what happens. We'll note that both the paint on both sides did fail completely, so there's that. So I shouldn't have any problem with this, but let's give it a shot. Yeah, pop that loose, no problem. Last test I want to do here is try out that timber screw mode. So I've got one of these 5" by 5/16 inch wood screws, and I'm going to drive it into this stack of 2x4s a couple times here and see if I can see any difference. You can see I've already been doing this a little bit. Can't see any difference just in, seeing it between the 2 and the timber screw mode, but we're going to actually time it here. I'll put the times in the bottom and we can see if it actually makes any difference whatsoever. So let's try it. This is in the 2 mode right now. All right, I'm gonna take it out and we'll try it again in this. That did seem like maybe it was a little bit faster. I'll put the times down below. Now, one thing I do want to try though is compare that with an impact wrench to the impact driver here. So I've got this atomic stubby impact driver. We're going to try it again with that. So I ended up splitting the wood. I've tried this a couple times and it keeps splitting the wood. Probably I've just used this board too much, but the impact driver spins almost 50% faster and it doesn't seem to slow down at all even when it doesn't split the wood. So I found the impact driver to be a whole lot faster driving screws like that than the impact wrench is. If you're using really big timber screws, something like this size, then the impact wrench makes more sense, but even fairly large ones like this, I think an impact driver makes more sense just because it spins 50% faster, so they go in a lot faster and it doesn't have any problem, it doesn't ever slow down on them. So I'm not really sure how useful that mode actually is. Last thing I want to do here is just take this apart, look inside. I mostly want to see how they're able to get this motor and impact set in here and have it be so small and so lightweight and still be able to put out that amount of power. So I'm going to pop it open real fast and we'll take a look. Alright, so looking at this on the inside, a couple interesting things. First thing I don't like is at the bottom here, the main connectors for the battery appear to be just copper. They don't usually, that's really nickel plated. It stands up a little bit better. The copper I would expect to corrode. Looks copper colored. Maybe there's some other coating on here. There's quite a bit of grease on there, some conductive grease I'm assuming, so that should prevent it in general, but I'm a little surprised to see that. The other thing is that the main battery wires that go onto those copper pads are just kind of soldered onto those pads and not particularly well. So if you ever have any problems, you might want to pop it open and see if that connection right there is broken. The other kind of sensor cables that talk to the battery itself, they're clips on, so that should be a lot better. It's kind of surprising that those are just kind of poorly soldered on there. A little disappointing. The rest of the whole electronics module is all nicely potted together. Always good to see. What really impresses me though is just how tiny this motor is. It's this section right here that's half-inch deep. That's it, and that's putting out all that power. The rest of this front section is a really nice machined aluminum. Well, it's probably cast, and then there's some machining done afterwards. And it's still not very big for the amount of torque that this puts out. And it's got this tiny little fan on it. I guess part of it is when you have a motor that's this small putting out that much power, it's got to be super efficient, so there's not that much heat that this generates. And this tiny little fan apparently is good enough to deal with that. Now, an impact wrench isn't something you're going to be running for hours and hours on end. It's not like a saw or something like that, so it may be that they can get away with that small of a fan on here. The other kind of interesting thing I noticed is that behind the motor section here, there's another section here that has these 5 wires going to it. And I don't know what that's for. I'm assuming it's some kind of sensor. The power wires for the motor at the bottom down here, and there's 3 of those, brushless motor, no big deal there. But then there's these 5 wires going to kind of the back end. I don't know why you would have 5 wires. So if anybody has any ideas what that might be, I'm guessing it's a sensor for those 2 bolt modes and timber screw modes. I'm guessing it's doing something with that, but I don't really know. I would have figured that would all just be done by the speed controller, because the speed controller can tell how fast it's spinning. So kind of interesting there. Well, I'm going to put this back together and then come up with some conclusions. This went back together really nice and easily, which is always a good sign. Feeling it feels really nice and rigid even after I put it all back together. I really like the design where they've got the 2 clamshells with the 1 piece on the back and then the anvil housing on the front here. That all kind of sandwiches it together and makes it really nice and rigid and durable. This is going to get dropped and beat around a little bit. I am surprised that they didn't put a little rubber pads on these parts here that stick up. They put them on the side here, which, okay, it's helpful, but it's probably not, most of the time if it's going to fall, it's going to hit up here. So that may end up breaking it if you drop it a couple of times. Obviously not something you want to do. So I really like this impact wrench. It's fantastic how much power it puts out in such a small and light package, particularly with these little power stack batteries. Generally, they're going to be put out plenty of power for everything you need to do. If you're working on a car or a light truck or something like that, you're going to be able to get out all the fasteners on that vehicle unless they're super rusty with that little battery. Otherwise, you may need to go to a bigger battery if something is really corroded. Just for comparison, this is the impact wrench that I've been using up until now, so you can see just how much bigger this is, and it probably weighs almost twice as much as this one does. Now, this will get any bolt I've ever run into off, puts out 1,200 foot-pounds, but it's so much more cumbersome to use than this nice lightweight guy. I really like this, really enjoy it. I do like that kind of bolt removal mode where it slows down as it's pulling the bolt off so it doesn't go flying away. I don't like it so much on the driving side where it stops after it hits the first time and pauses for a second. I always get a little confused by that. Maybe if I use this every day, I'd get used to it and really like that. Timber screw mode, I don't really know what it does or what its purpose is. So if you particularly like that mode, if you know any differences besides just optimized for timber screws, really like to hear that in the comments below. Same thing about that bolt mode if you like it or don't like it. Leave a comment below. Other than that, thanks for watching. Give this video a thumbs up.